Today we're going to start. Yesterday we started talking about atoms, the structure of atoms. Today we're going to advance a little bit further and do a little prep work that we need to do in order to understand electron configurations. So we're going to get into atoms with elements with their electron configurations next week. But in order to do so, we have to have a little bit of background information on some certain things called quantum numbers. So today, all we're going to do is discuss quantum numbers. There are 4 of them. This stuff that we're doing, this material, we'll put it all together next week. So if we go through this and it doesn't make sense to you yet, be patient, okay? Because it's a whole thing with the big picture, and we're only doing a little part today of the big picture. So it'll make more sense when we put it together later, I hope. Atomic orbitals and quantum numbers. We talked yesterday about the Bohr atomic model. What did we give the Bohr atomic model its nickname? What did we say it was? Well, Bohr is boring, yes. We named his version of the atomic theory. What did we call it? Parker? The planetary model. Because remember that Bohr stated that the electrons orbit the nucleus. The electrons orbit the nucleus. So, in the Bohr model, electrons of increasing energy occupy orbitals farther and farther away from the nucleus. So in terms of electrons with energy, the ones up close to the nucleus have the lowest energies. The one furthest away from the nucleus has the highest energies. We better get a definition of an orbital in our notes. An orbital is a 3-dimensional region located around the nucleus that indicates the probable location of an electron. So an orbital just states where there might be an electron, okay? The probable locations that the electrons could be at. We're going to discuss today 4 different quantum numbers. And these quantum numbers specify the properties of atomic orbitals and the properties of the electrons that are on these orbitals or in these orbitals, these circular paths. So these quantum numbers will describe certain things about the electrons and the orbitals in which they are occupying. Let's jump right in with the principal quantum number. Okay, the very first quantum number we're going to talk about, the principal quantum number. We'll get this entire slide up there, and then we will discuss it. I'll give you a second here to write it down, and then we'll discuss it. All right, so the principal quantum number is symbolized by the letter N. So if I might ask you, well, what is letter N? Or what is the main energy level? Okay, we are talking about the principal quantum number. As N increases, the electron's energy and its distance from the nucleus also increase. So as N gets bigger, it gets more energy farther away from the nucleus. An electron for which N equals 1 occupies the lowest energy level and is closest to the nucleus. More than one electron can have the same value for N. These are said to be on the same electron shell. Okay, so once again, oh, I got that. Once again, N is the symbol for the quantum number, and it's the distance. It helps us understand distance from the nucleus. Go ahead and take out your periodic table. We're going to do some writing on it. We're going to write that baby up. Get some stuff on it with these quantum numbers, starting with N, the principal quantum number. Now, PEL, P-E-L. If we talk about the PEL, the principal energy level. Now you're going to see, and I want you to write directly on your periodic table. I want you to put these guys right here. So off to the left of that table, I want you to number 1 through 7. Those are the 7 main energy levels, which we call the principal energy level. So, if I would ask something like, what energy level is magnesium on? You find magnesium right here, and you say, oh, it's on principal energy level 3. So its main energy level is 3. If I would say something like lead, right here, what energy level is lead on? 6. Okay? So we can look at the energy levels and know where they're at based on the numbers to the left of your periodic table. Yes, sir. Yes. Yeah, the ones at the bottom, just fit them in where they go on the table. All right? Now, what you're going to see here is based on overlapping and stuff that occur, that the numbers are going to be a little bit different. It's not quite that easy. Okay? It's not quite that easy to say, all right, since the lanthanide series fits right in here, that they're going to be on energy level 6. We're going to get to that, but it's not just that easy. I'll show you how to do that, though. Okay? Because it's a little bit different with the D block and the F block, which you have no idea what it is yet. Okay? But let's make sure we got those 1 through 7 labeled on the left hand side of our periodic table. The second quantum number is the angular momentum quantum number. The angular momentum quantum number is symbolized by the lowercase l. So once again, that's not an I, that's a lowercase l. It indicates the shape of an orbital. Now, when you hear me talking about the angular momentum quantum number, you will hear me talking about sublevels. I won't say what is L, I'll say what is the sublevel. Okay? Except for the first main energy level, orbitals are of different shapes are known as sublevels or subshells. Okay. These exist for a given value of n. So we will have main energy levels, which is n, and then we will have sublevels. Those sublevels we assign letters to. So the sublevels will be indicated by 4 different letters. Excuse me. Because there are 4 types of orbitals: S, P, D, and F. S orbitals are spherical. P orbitals have a dumbbell-like shape. D and F orbitals, I can't really describe what they look like because they're pretty complex. So what we're going to do is my next slide, I'm going to show you the different orbitals and their shapes. I'm going to show you the different orbitals and their shapes. So, here we go. Up at the very top here, this is S, spherical. These yellow ones are the 3 p orbitals. These purplish, bluish ones are the 5 d orbitals. And here are the 7 f orbitals. So I guess the big thing that you might want to write down you just wrote S has a spherical shape. You know, you might want to number that S has 1 orbital, P has 3 orbitals, D has 5, and F has 7. 1, 3, 5, 7. The number of orbitals that exist on those main energy levels. Each atomic orbital is designated by the principal quantum number followed by the letter of the sublevel. The principal quantum number, which is the main energy level, and the sublevel. So, for an example, The 1s sublevel is the s orbital in the first main energy level. The 2p sublevel is the set of 3 p orbitals in the second main energy level. Now, once again, I don't expect you to understand this. I expect this to be confusing because you're probably going 2p, 1s, you know. It could be another one, 3d. I don't expect you to know this, so let's just get the background data down. Know that, number one, when I have 1s, 1 is the principal quantum number. The s is the angular momentum quantum number. That's all I want you to know for right now. Be able to recognize, oh, okay, the main energy level, that's the number 2 quantum number. Okay? Okay? The p is the angular momentum, quantum number, or the s, or the d, or the f. The third quantum number is the magnetic quantum number. Get that down, and we'll talk about that here in a second. The magnetic quantum number, the third of our quantum numbers, is symbolized by the letter m. It indicates the orientation of an orbital around the nucleus. We stated that the angular momentum quantum number, the shape of the orbital, was the second quantum number. We know that the s orbital is spherical in shape. Okay? It only has one possible orientation around the nucleus. However, how many p orbitals did I tell you there were? 3. I told you there are 3 p orbitals. So, if I look at those 3 p orbitals, I can say, well, they are oriented in 3 different ways. They extend along the x-axis, the y-axis, and the z-axis if we're looking at a 3-dimensional coordinate system like graphing system. Therefore, with the p orbitals, we call them the p sub x, the p sub y, and the p sub z orbital. So once again, okay, you'll hear me refer to these as px, py, pz. So let's say we have an electron that is on the second main energy level. It is in the p orbital, and we can say specifically how it's oriented in the p orbital. Is it the px orientation, the py, or the pz? So you might hear me say something like 2px, 2py, 2pz. Those are the 3 orbitals on the second main energy level with this p sublevel. Now, here are the orientations that they are talking about. X, Y, and Z. And it just shows the difference of how they are oriented around the nucleus. The nucleus would be somewhere here, right in the middle. So this one lies along that z-axis here. This one is along the y-axis here. And this one is along that x-axis right there. So those are different orientations around the nucleus. There are 5 different d orbitals, so I told you. 5 different d orbitals. The d sublevel has 5 different orbitals, and I'm not real concerned, folks. You're going to see here, you don't want to draw these out. Okay? You saw them before. They are a little bit bigger. And I'm not going to require you, if you look, just like we said, PX, PY, and PZ, okay, those are pretty easy. I'm not going to have you see these D's. This one is the DXY. This one's the DXZ, DYZ. Okay? We don't need to know that, which specific names of the d orbitals. All right? So we won't know that. The big thing to know with this is how many d orbitals are there? 5 of them. There are 5 of them. That's the main thing. Now, what did we say about F? 7. We said that there were 7 different F orbitals. And if you remember, I told you that the F is very complex. Well, here's the picture of the 7 F orbitals. Okay? And once again, they're talking about the coordinate system with the X, Y, and the Z. So this one right here that I got my pointer on right there, this one right here is F Z to the third 3ZR2. Okay? Once again, way in depth. What you need to know about this is how many orbitals are on the F sublevel. And that answer would be 7 orbitals on the F sublevel. Now, our final slide that we're going to talk about today is the spin quantum number. It is the last of the 4 quantum numbers. The last of the 4 quantum numbers. The spin quantum number deals with the spin of the electrons. A single orbital can hold a maximum of 2 electrons, which must have opposite spins. And I want you to write those 2 things down, those 2 pictures there. We'll talk about them. Now, what is this box with this arrow telling me? Okay? This box right here is an orbital. Okay? Since I know that this is hydrogen, okay? Hydrogen has only 1 proton and 1 electron. The arrow represents electrons. Okay, so that arrow will represent an electron. So, here's hydrogen. Hydrogen is on the main energy level 1. Okay, it's on the first energy level. Look at your periodic table. How many electrons are on, or how many elements, let me say it this, how many elements are on the first energy level? 2. Okay? Hydrogen and helium. Now, if you look at that, okay? You look at that. Here is the first energy level. What type of a sublevel is it? S sublevel. Okay? So, the orbital here is an S orbital. How many electrons are on this S orbital right here? 1, because it's got 1 arrow. Now, here's another S orbital. It has 1. It has 1 going down. And this is how we indicate 1 up, 1 down, 1 up, 1 down. That's how we indicate the opposite spins we're talking about right here. The opposite spins. So this one has 2 electrons on this orbital. Each orbital can hold how many electrons? 2. Now, let's go through and let's do some thinking. Okay, let's do some thinking and make some sense of this. How many p orbitals are there? 3. Each orbital can hold how many electrons? 2. So how many electrons can be on that p sublevel? 6. Let's go now to the d. How many orbitals are there on the d sublevel? 5. Each one holds 2 electrons. So how many are on the d sublevel? 10. Okay? Now let's go to the f. Let's go to the f. The f sublevel has how many orbitals? 7. How many electrons on each orbital? 2. So how many total? 14. Okay? Those things are important to get into your mind when we're talking about these. All right? I want you to find the lanthanide series on your periodic table. Remember where we said that was? Where's it at? What does the lanthanide series begin with? What number? 58. Now find that. Find the lanthanide series 58. I want you to count how many elements are in the lanthanide series. 14, right? How many electrons did we just say was on the F sublevel? How many electrons? 14. Do you think that's a coincidence? Okay. I think not. I think not. I want you to point to boron, number 5. Start with boron and count to your right. How many are there? Boron, carbon, nitrogen, oxygen, fluorine, neon. How many? 6. Okay. What sublevel had 6 electrons on it? P. Do you think that's a coincidence? I don't either. So we're going to bring this stuff together. I just wanted to show you just a little bit right there. We're going to bring this together more next week. But, ladies and gentlemen, I am telling you that those things, like I just showed you, 14 electrons on the F block, on the 7 orbitals in the F block, 14 elements across the lanthanide series. This stuff makes sense with your periodic table when we put it all together, which will be next week.